Okay, the next example starts off with a circuit like this. So similar to the other one, but with different values. So 12 volts, we know a bunch of resistances. In a problem like this, probably, unless the answer to whatever is being asked is super obvious to me, probably one of the first things I would do is find an equivalent resistance. And that's what I did here in the solution for this. So the first thing I can kind of think of is I can find out the equivalent resistance of these two just by adding them. So I add those would be 30 ohms. And then I have a parallel circuit, so that I'd find the equivalent resistance there. And then I'd end up with 3 resistors in a row, and I could find that equivalent resistance. So, excuse me. So in fact, that's what I did here. These equal that. So then what I did is I replaced this parallel circuit with just 1 R6. So 1 over R6 is 1 over 10 plus 1 over 30. So that's 4 over 30. Therefore, R6 is 30 over 4. And at that point, then, I have a circuit that looks like 10, 15, 30 over 4. And I can just add those up. So RT is 10 plus 30 over 4 plus 15. That equals an RT of 32.5 ohms. So in other words, these two circuits are now electrically equivalent. This doesn't change. This is the voltage source. There's some current going through one total resistor of 32.5 ohms. And with that, I can find out what this current is. So in other words, what I'm finding is this total current here. So using Ohm's law, V equals IR, so I equals V over R. 12 over 32.5, I get a current of 0.379 amps. So I now know this current. So once we have this things with total current, we can find all sorts of things. We can get the voltage across each thing. So let's just try calculating some of those. So V1, we know this current. We can get this voltage V1. So V1 is I times R. So I times 10 R1. So 3.7 volts. Now I can find R5. I'm not going to round numbers here. Because we're going to be doing a lot of calculations, I don't want to do any rounding. So I'm going to go, because these all have the same 12. That makes it kind of easy. Divided by 32. So V5 is that. So it's R5. I'm going to use 0.37 times 15. So use my calculator for that. I mean, it's a little bit of rounding, but not quite as much. So this is 3.69 volts. And V2 is okay. I'm not going to do V2. Once I know that, I can figure out. So this current voltage is, that same current is right there. So V5 is I times R5. The gain is equal to all the things that drop. So we have 12 equals 9 times 3.7 plus R5, which is 5.55. Plus so I get 5 V2. So V2 is equal to 12 minus that. Okay. 3.7 minus that. I get 2.75 volts. So we know that voltage. If I know V2, I can get. We should be able to figure out this voltage. I2. V2. I2 think is V2 Ohm's law R2 around that loop. All the voltage gain, which would be the 12 volts, is equal to the voltage of all the voltage drop, which is V1, V2, amps. So let's calculate V2. So if I call this 12 volts, I can calculate that because this main I is equal to I2 plus V2 plus 5.535. So solving for V2, 0.275, I get an I3 equal to 3.69 plus that, subtract that from 5. So I get 2.77095 volts. And with that, I can get these two. So we know that voltage. If we know this voltage, we can get the current. Let's go through that and just double check that it all adds up. So I'm going to go is equal V3 to V2 divided by R2. I3 R3 5 divided by 10. So that's an easy one. That's just 0.295 volts.
Let's call it 2
And V4 is, and current. So I know this I, and I know I2, so I should be able to get I3 times 20 using Kirchoff's current law. So it's 0.95 twice. I equals I2 plus 1.9. So this is 0.369. These two voltages from that point to that point, so the voltage of R2 has to be the same as 0.278 plus I3. So I get I3 is equal to 0.197. Okay. Okay, so that's an example of how we can calculate a whole bunch of things from a circuit. We could also find the voltage across R3 and R4 by using the current and the resistance. But I think that's good enough for this problem. So one last example. Here's the circuit. It says find the voltage across the 3 ohm resistor. Now, with circuits, there's a lot of times you won't know exactly what steps to get from the question or from the circuit to the actual answer to the question. And that's okay. If that's the case, just treat it like a goalless problem. Just find out as much as you can. And usually one of the first good steps you could do is to find the equivalent resistance of the circuit. Once you've done that, just find one new value. And once you have a new value, you can find one more. And if that's the answer to the question, fantastic. If not, back to here, find one new value. With that new value, find one more. Just keep seeing if you can find your answer. Treat it like a goalless problem. So I can see here, I know all the values of all of my resistors, so I can find equivalent resistance. So first of all, I'm going to find the equivalent resistance of those two resistors in parallel. I'm going to replace it with this, I'm going to call it R parallel. So 1 over R parallel is equal to 1 over 3 plus 1 over 6. So that's 2, that's a half. Is that a half? That's a half. So R parallel is 2 ohms. And then if I had a circuit that looks like this, so that's 4, 2. I'm going to make an equivalent circuit with just one resistor. And that RT is equal to 4, so that's 4 plus 2. So the equivalent resistance of this circuit is 6 ohms. And once I know that, I can find the current that's flowing through the voltage source. I can find this current. So I is equal to 12 volts divided by 6 ohms. It's 2.0 amps. Awesome. So now I know this current here, I. And because I know that current I can figure out the voltage through, I'll just call this R4. Okay, so let's do that. I'm going to find the current through R4. So, or sorry, the voltage across R4. So V4 is equal to I times R4. So that's 2 amps times 4 ohms. So V4 is equal to 8.0 amps. So it's like I found the equivalent resistance. I found one new value. Didn't answer the question. Okay, so I found a new value. V4 is 8. Did not answer the question. Okay, so I'm just going to find one more. I am going to find the voltage from that point to that point. So if I think of Kirchoff's voltage law, the voltage along that loop, the total voltage along that loop has to be 0. So the total gain is equal to the total drop. So each time the current goes across resistor, the voltage drops. So the gain is 12 volts. It drops across the 4 ohm resistor, which was 8. And it drops across through a 3 ohm resistor, so I'm going to call that V3. So V3 is equal to 4.0 volts. Done. That is what the question asked, and that's what I found for it. So that answers the question. I also, without doing too much more work, I also know that V6 is also 4 volts. And I could also find the current across. I can call this I3 and I4. I'm just going to quickly do that because I can. I3 is equal to V3 divided by R3. So that's 4 divided by 3. So that's 1.33 amps.
Good afternoon, teaching staff and support.
And I could do the same for the current I4. I4 is V4 over R4. So V4 is it's the same. 4 volts divided by 6 ohms. So that is 2/3. So that's 0.67 amps. And I also can tell if I add up these two currents, I3 and I4, it should be equal to the just I, because the total current going into that junction is the current coming out. So 1.33 and 0.67 equals 2, and that is in fact the current of the circuit in this point. So there you go. Yeah, find the equivalent resistance if you can. If not, continue on and just find one new thing as you go along.